Hey, welcome back in the shop. This is part 3 on the Tripan 111 tool holders, and as you can see we have come pretty far. We started out with a bar of ground flat steel, and now we have a piece that has quite a lot of machined features on it. What I did off camera, I turned the height adjustment screws that go in here. They will later be Loctite in with high strength Loctite, and also I made the height adjustment nuts. These are just turned from drill rod, knurled, tapped, parted off, and then hardened. I wanted them to be hard as the original ones. On a real Tripan made in Switzerland, on the original tool holders. Oh, by the way, here you can compare. This one is an original one, and the left one is made by me. So I think I got pretty close. What they do, that you don't accidentally change your setting on the height adjustment screw. They mill a slot into the screw and they drop in a piece of flat spring steel that has a bow to it, and that holds the height adjustment nut in place. It gives some friction onto the threads. And when I made my first set of eight holders, I was thinking about doing that too, but I decided against it and just used a plain threaded rod and the nut on it. And my threading is tight enough, so tight enough, so this is not a problem. I picked them up on the height adjustment screw, but as the thread is tight enough, it's no problem that it changes settings. And if so, it's also not a big problem. Just loosen the tool post clamp and do a very light adjustment. I have constantly to adjust these because I use tools. I don't use inserts. I'm using tools that are regrind, and by regrinding them on the top surface you change the center height anyway, so not a big problem there for me. But I don't want to go through the hassle of machining a small slot into each of them and bend a small leaf spring and so on and so on. So that's how I did it, and I did it off camera because this is very straightforward. Right now I'm in the process of chamfering the edges of the dovetail, and I was not willing to do this by hand with a file because 10 holders, and each has two sides, so 20 times the same contour to debur and chamfer. I was not willing to do that. I cut myself a small template and I'm doing it on the Pantograph machine. So let's go over and have a look how I do it. Okay, here you can see the template. It's a 4:1 ratio and it's cut from 2mm styrene, just cut out with a jeweler saw and a razor blade. And then some scraping on the surfaces to make it smooth. That's what I use to give me the tool path for deburring. Okay. I have the vise here on the engraving machine with a stop setup, which is only a strap clamp that I use for that job. I drop the workpiece in against the stop, make sure it's flat in the vise, clamp it down, No need to crank it down like crazy. We're just running a 6mm 4-flute carbide deburring bit in there. And now that fast you can deburr a contour if you have more than one. Make a template and run it on the engraving machine. That's way faster than doing it by hand. You could also do it with a guiding pin below the deburring bit, but I found that with pretty high workpieces it can get a bit hairy. The guiding pin, like on a pin router, works very good for flat workpieces, but not for something that is higher than its wide, because it tends to tip. Now we can take a workpiece, clean out the vise, turn it around, drop it in, clamp it, and do the second side. And done. Nicely chamfered on both sides, here and there. So that's it for the dovetail. Now we see what else we have to do. Okay, I want also the tool bit slot to be chamfered, and also this would be 20 edges to file a nice chamfer on it. While I can do it, I'm not willing to do it by hand. And if some of the older gentlemen out there now might say, oh, back then in the days we hadn't fancy machines to do this, you would have used them if you had them, so don't blame me. And you can't do it that fast by filing. And in a second I will show you that for such work you don't even need a real template. You can use the machine's template table for such operations. Okay, that was the last one. Now I'll show you what's going on the template table. As you can see, there is almost nothing going on the template table. The part we want to deburr has two straight edges, so the template would look like a piece with a slot in it, and that's what we have here already on the template table. We can use a straight stylus and follow the edges that are in our table, in the template table already, and by figuring out the right scaling factor, I can deburr both edges by running the stylus down. Then I have an end stop, a stop block, to know when to stop without looking. Go over to the other side and return. Move it out of the way. Change the part down on the actual machine table. and come back in and do the next piece. And that's not even hard to set up. This was about 5 minutes setup time. So that's the engraving machine and pantograph machine, or the die sinkers. Those are super universal machines. You can do a lot of them. If you get creative with the templates and the stuff you have, you can also clamp a straight edge to the table when you want to machine just an angled slot or an angled step into a workpiece. Okay, the original Tripan tool holders have a number engraved here, and this number says the first number, the 1, is the size. All these holders are size 1. The second 2 numbers determine the type of the tool holder. 32, like this, is a 30-degree angled holder with a square slot. There's also one with a bore that has another number. And I have straight holders with a slot. And that's a size 1, type 31. So we're going to engrave a 131 into each of these tool holders. And I'm not sure if I ever showed how to figure out to set the pantograph ratios for engraving. And yeah, let's do it. First we have to measure the height of our engraving that we want to have. So we take our scale, and this is a about 3mm high engraving. Then we need to know how big our master copy is. And these are a strange odd number. They are 17.5mm high from the top to the lower end. And now to figure out the ratio, we take the 17.5 divided by 3, and the ratio is 5.8. We could set the pantograph to 5.8 without a problem, but I prefer to go with even numbers. 5.8 is very close to 6, so we do the math and check how big the engraving would be on 6:1. So we take our 17.5 divided by 6, and it would be 2.91. So 800ths off. And that means we can go with 6:1 scale. Pantograph has 2 bars up here where you can set your ratios, and both need to be set to the same ratio. They have engravings for even ratios on this side, and on this side is a metric scale with a vernier scale on the slider, so you can calculate and set uneven numbers. We could set the 5.8 ratio over here, but as we saw, the variance when we go with 1 to 6 is not too big, so we use the front scale. So let's move it to 6. And the setting of the dial has to be quite accurate, because otherwise you would get an engraving on a curve. The second setup is done up here, and we move it to And you saw me just move the whole pantograph a few millimeters to the front. And that has the reason that with some combinations of settings you get the pantograph linkage in a position where it binds, so you have to get it out of the bind by moving the whole pantograph. Now for the master copy on the template table, we slide in our master copy that we selected before. Make sure there is no dirt in. And we put a stop on both sides of the master copy, so it can't move. Then we set a stop block on both sides of the master copy so it doesn't slide around. And the position on the table is not critical at this point. You just put it somewhere where it's convenient, clamp it, and then you need another stylus. This is a cylindrical stylus I use for duplicating or copy milling, but we need a stylus with a point, and these stylus have to have, these are, I hardened and polished them. They need a pretty good surface finish and the tip needs to be rounded. You can't use a sharp point in the master copy, you will ruin them. And the master copies are pretty expensive, so you better watch out on them. Then you drop in the pin and set the height. Some people tend to put a load on the pantograph arm. They bend it up a few millimeters and clamp the styli. So the stylus is always pushed down into the master copy. Don't do that. That ruins the master copy, the linkage of the pantograph, and it gets hard to move, and the probability of slipping out of the groove of the template increases because you have to use more force to move it. I prefer just let it drop down into the slot without any force and clamp it. That way it moves very lightly, and when you set your hand on top of it you have enough pressure so it doesn't slip out of the master copy. And you can change from number to number without having to bend the pantograph very much. And now, as we have set our ratios and also I moved the table to the right position and clamped it in place, we can do our engraving. I have a 0.8mm ball nose carbide end mill in there, which I prefer for engraving over the V-bit V-style engraving bits because they leave a nicer finish. And now I need to set my depth of the engraving and we're good to go. So fire it up and I'm moving up the table. And I did a first very shallow pass to see if everything is right. I barely scratched the die cam, the layout paint. One done, 9 to go. Okay, I got all 10 of the tool holders done. I cleaned up all the edges, I deburred everything, there are no sharp edges left. Everything is slightly rounded over or cleaned with 400 grit emery paper, and the parts are engraved, they fit, and everything is great. Only thing that's left to be done is to finish them, and I want to have them a black finish, and I'm doing this by heat blackening. That means I heat them up and then I drop them in oil to quench them, and by the quenching some of the oil burns and settles itself onto the surface. And normally I would do that for small parts just with the torch, heat them up and drop them, but as these parts are quite massive and there are 5 of them, I dragged out my little oven, my little ceramic burning oven without regulating. That means I have my multimeter with the thermocouple up here to monitor the temperature, and I can somewhat regulate the temperature by turning it on and off. We're now at about 550 degree air temperature in there, and the parts get some color, some heat discoloration. But as we have quite a lot of mass in there, we have 5 of the tool holders, that's about 2 or 3 kilograms of steel. That takes some time that the heat soaks into the parts. I don't want them to be glowing. I want them just to be about 400-500 degree all through. So I will let them soak some more time, and then we'll take each one out and quench it in vegetable oil. Okay, let's take a look. And think. Yeah, that's a nice color. That's some bluish, blackish, and we quench it. Okay, the one that was directly in front of the door needs some more time. As I opened the door, it cooled down too much. As you can see, this is quite a bubbly mess, and this would really hurt if I got it on my skin. That's the reason for the heavy welding gloves. And here we take out the remaining ones from the oil. And as you can see, the oil is very, very thin due to the extreme heat. I have to correct myself. This is not really heat blackening. For heat blackening, the temperature would need to be considerably higher, so the oil really burns. But I don't want to take any chances of warping these parts, so I go with the heat coloration and the oil soaking. The oil acts more of a quench to stop the pieces from changing color anymore. The heat coloration depends on the temperature and the time. If you hold it 300 degree or something like that, is a bluish color. if you go to 250 and hold it for long enough, it will also get blue. So when it reaches the right color and drop it into the oil, it freezes the color. So that's okay. And the oil bath also gives it some protection from rust, even if it's not really burned in. But I will later wipe them down just with a clean rag, and that will leave some oil film on there that's rust protected. Okay. After heat coloring, I finished them off camera. Essentially what was left to be done is to glue in the height adjustment screw with Loctite 648, that's a bushing glue, high strength, and screw on the height adjustment nut. And what you see here are the 10 new Tripan 131 holders. One 30-degree holder, a Tripan 132 that I made about 2 years ago, and it's still in great shape. And in front here we have a original genuine Swiss-made Tripan 132 holder, as can be seen by the logo of Tripan, and of course the dovetail on these is ground, and these are hardened. Everything on an original Tripan holder is hardened. The holder, the screws, and the height adjustment nut, as it's mine. So the only last thing that's left to be done is to machine some screws, and I made, for the holders I made 2 years ago, I made 8 sets, that's 18 screws. I machined them, I threaded them, and I milled the square head. And that takes some time. That's a pretty boring job, but I don't want to use hex head or screws with an internal hex or bolt screws. I want them to be absolutely the same as the original ones. So I'm going to make another 30 of these screws. But I will not film this. This is just turning and parting and threading and milling, so no video on that. But I hope this the making of these holders was interesting for you, and I wanted to show that it's pretty easy to make holders for dovetail style tool post, as there are not only the Tripan holders out there, there are of course the Phase 2 holders or the Aloris type tool holders and a whole lot of more. There are also some that have a T-slot like the Dickinson type, I think, and so on and so on. And for all these you can pretty easily make your own tool holders. The only one that's really hard to make yourself is the multifix that's common here in Europe. And that's also the reason why I sold my multifix holders and the tool post itself and changed to a Tripan. Now I have 19 quick change holders. That's something to work with. I'm very happy with that. So thank you for watching and see you next time.